Good day, students. The last time we met, we are through with the topic nitrogen and its compound. And by the grace of God today, we are moving on into a new topic called carbon and its compound. Just like nitrogen that we just finished treating, nitrogen is a nonmetal. As well, carbon too is a nonmetal. So we're going to look at the chemistry of carbon, and we're as well going to look at the compound of carbon. This topic is very important in the sense that it dovetails into the aspect of organic chemistry called hydrocarbon. By the time we get to the compound of carbon, we're going to look at that in detail. But carbon, as we know, is a nonmetal, and like I said, it's a group 4 element. It has atomic number 6, electronic configuration 2,4, sp notation 1s2, 2s2, 2p2. It's an important element because carbon is present in plant tissue, carbon is present in animal tissue. Carbon plays vital role or is a major element in crude oil. It's an important element in most organic compound. In fact, it forms a skeleton called carbon skeleton in most organic compound. Carbon is an important element. Like I said, it's one of the elements that has a relish of forming a long chain with itself by the process called catenation. Carbon has the ability to catenate. It joins with itself, forming a long chain, and we call the process catenation. So we're going to look at this in detail as we move on, and we're still equally going to look at the compound of carbon ranging from carbon 2 oxide, that is carbon monoxide. We're going to look at carbon 4 oxide, that is carbon dioxide. We are going to look at a salt as well, triisocarbonate 4. Going to look at various reactions, the physical and chemical properties. We are as well going to look at the carbon cycle. And we are going to look at all this as it affects the nature. So as we start, we'll see more of this. Like I said earlier on, carbon is a member of group 4 elements, as we know. It has atomic number 6, electronic configuration 2,4, sp notation 1s2, 2s2, 2p2. Meaning, carbon has 4 electrons in its outermost shell. And these 4 electrons it has in the outermost shell are used for bonding. If you look at diamond, an allotrope of carbon, the whole 4 electrons in the outermost shell of diamond are used for bonding. And that makes diamond to be the hardest substance known. But for graphite, another allotrope of carbon, out of the 4 electrons in the outermost shell, 3 are used for bonding. The remaining 1 electron keeps moving around. And that makes graphite to be 1, soft, 2, to conduct electricity, 3, to be used as lubricant, 4, to be used as electrode. So that 1 electron that is called the localized electron that is moving around within the ring has conferred that peculiarity on graphite. Having said that, carbon occurs naturally as diamond and graphite. It also occurs in an impure form as coal, and in the combined state as carbon 4 oxide, natural gas, petroleum, even and wood. Other sources of carbon are mineral deposits of metallic triisocarbonate 4, such as calcium triisocarbonate 4, known as limestone. That's what we use in making cement. Also, magnesium triisocarbonate 4, which is otherwise called dolomite. Carbon shows little tendency to acquire 4 electrons to form an anion, C4-, or to lose 4 electrons to form the cation C4+. Rather, it forms 4 covalent bonds. Carbon has the ability to form a long chain with itself, and that process is called catenation. Carbon has the ability to form a long chain with itself, and we call it catenation. So carbon can catenate. Carbon is commonly present in plant and animal tissue. There is carbon in our body as an animal, human being. You know, in our body we have protein. One important element in protein is carbon. In our body we have carbohydrate. One important element in carbohydrate is carbon. In our body we have fat and oil. One important element in fat and oil is carbon. So carbon is present in animal tissue. In plant tissue, carbon is equally present in plant tissue. You know, in plant we have starch and we have other compound. And if you check, the important element in starch is carbon. So carbon is present in plant and animal tissue. Still on that, we are quickly going to look at the oxidation state of carbon in its various compounds. You know, carbon exhibits oxidation state of +2 in some of its compounds and equally +4 in some of its compounds. It exhibits oxidation state of +2 and +4 in its compound. Allotrope of carbon. Allotropy is a phenomenon or is the existence of an element in two or more different forms in the same physical state. Let me take that again. Allotrope is the occurrence or existence of an element in two or more different forms in the same physical state. Let's now look at the allotrope of carbon. Like I said earlier on, we have diamond, an allotrope of carbon. We have graphite, an allotrope of carbon. And we have another one that is not a true allotrope of carbon, we call amorphous carbon. You know, amorphous carbon is not a true allotrope of carbon simply because it contains minute crystals of graphite laced with some impurity. So that's why we don't see it as a true allotrope of carbon. So amorphous carbon is not a true allotrope of carbon because it contains minute crystal of graphite laced with some impurities. However, diamond and graphite, they are crystalline form of carbon, while amorphous carbon is non-crystalline form. Let's look at the differences between diamond and graphite. Let's start from color. Diamond is transparent in color. You know, it has high reflectivity, so it is transparent in color, while graphite is black and opaque. Let's look at the texture. Diamond is the hardest substance known. Remember when we started this topic, I was telling us that the 4 electrons we have in the outermost shell of carbon, that in diamond, the whole 4 electrons we have in the outermost shell are used for bonding. And that makes diamond to be the hardest substance known. Why for graphite, out of the 4 electrons in its outermost shell, 3 are used for bonding. The remaining 1 electron keeps moving around. We call it the localized electron. And this 1 electron that is moving around has conferred some peculiarity on graphite. And that even makes graphite to be very soft. So you can see on the table here, in terms of texture, diamond is hard, while graphite is very soft. Let's look at density. Diamond has a density of about 3.5 grams per centimeter cube, while graphite has a density of 2.3 grams per cm cube. Meaning, diamond is denser than graphite. Still on shape, crystal shape, diamond is octahedral, while graphite is hexagonal. That is talking about shape. Diamond is octahedral, graphite is hexagonal. Now let's look at electrical conductivity. Diamond is a non-conductor of electricity because it doesn't have the mobile electron within its structure. So it is a non-conductor of electricity, while graphite is a good conductor of electricity because of the presence of mobile electron. Now let's look at the hybridization. Diamond is sp3 hybridized, while graphite is sp2 hybridized. It is important to note at this juncture that when you burn both allotrope in air, they both produce carbon dioxide. And that shows to us that they are allotrope of the same element called carbon. Let's look at impure forms of carbon. That's amorphous carbon. Charcoal is one of impure forms of carbon that we have. You know, charcoal is obtained when wood is burnt in air. Charcoal occurs in many forms. So you can burn wood to have wood charcoal. You can burn bones of animal to have animal charcoal. You can burn sugar to have sugar charcoal. So even you can burn fuel or oil to have lamp black and soot. So when we say charcoal, it goes beyond just wood charcoal. So charcoal could be in many forms. Let's look at this form one after the other. Wood charcoal is made by burning wood in limited supply of oxygen. When wood is burned in limited supply of oxygen, you have wood charcoal. And this wood charcoal is very, very important. We use them as fuel. We have seen that in our neighborhood, where people will put charcoal, you know, and they prepare fire from there. So we use wood charcoal as fuel. Also, we use wood charcoal as an absorbent for gases. It can easily absorb gases. It's an absorbent for gases. Wood charcoal may be used as fuel, may be used as absorbent for gases. Let's go for another forms of charcoal, animal charcoal. Number 2, animal charcoal. So animal charcoal is made by heating bones. By heating bones in limited supply of air. When bones of animal are heated in limited supply of air, you have animal charcoal. Animal charcoal is a good absorbent used for decolorizing sugar. Anytime you want to decolorize sugar, we use animal charcoal because it's a good absorbent used for decolorizing sugar. The another forms of charcoal is called sugar charcoal. Sugar charcoal is made by heating sugar in the absence of air. At this stage, we should be careful with the language usage. This one is made in the absence of air. I mean sugar charcoal. Wood charcoal is made in limited supply of air or oxygen. Animal charcoal is made in a limited supply of air. But when it comes to sugar charcoal, it is made by heating sugar in the absence of where we should be careful with the language usage here. You can see the equation where sugar is charred. We call it charring of sugar to give you coke plus water vapor. So that is how to prepare sugar charcoal. Then the last one is lamp black and soot. Check. When you allow oil to burn, burning of oil, fuel oil, or gases containing carbon compound in insufficient air, please, we should be careful with the language usage. Insufficient air. Anytime you burn fuel oil, anytime you burn a carbon containing compound in insufficient air, you are having the lamp black and soot. Like I said, in our various homes, let me scale down to our various homes. You know, the old lantern that people use in olden day, they put kerosene. Some will use kerosene, some will use oil, red oil. So by the time you put that fuel in that lantern, with the wick that will bring about light, you discover that the bulb of that lantern will become blackened with time. So that speck of black deposit that you see there is called lamp black. And that black speck that you see on the wall of that bulb, of that lantern, called lamp black, is as a result of burning of fuel oil. So when fuel oil is burnt, it needs sufficient air. You know, you will not allow air to enter inside that bulb, or else that thing will not bring out light the way it should. So anytime you burn fuel oil or gases containing carbon compound, it needs sufficient air, you are having your lamp black. One may now ask, what are the uses of this lamp black? Lamp black is used in making gramophone record. Nowadays, gramophone record, we use lamp black in making printers ink. We use lamp black in making black paint, even shoe polish and rubber tires. That's application in production of all these products I just mentioned. Now, talking about soot. Soot is usually deposited on material and is derived from burning oil. When you allow oil to burn, you see soot that is deposited on its surface. The soot is always formed when you allow fuel or oil to burn. You see the deposit called soot. So by the grace of God, we will stop here today. So next class, when we meet, we'll be looking at the property of diamond, property of graphite, uses of diamond, uses of graphite. We now move over to coal, different kind of coal that we have, the hard coal, the soft coal. We're going to look at the uses as well. Then from there we move on to the compounds of carbon by the grace of God. So I hope you guys enjoyed this class. So next time, God willing, we'll continue from there. Have a nice day.